Hi all, in this video we will discuss transpose of a linear transformation. For that we consider a linear transformation T from V to W. We consider this is linear transformation from V to W. Then we corresponding to each transformation T, we define a linear transformation T transpose. So this is defined from W star to V star. Okay, so that means if you consider V here and this is our W, and we have transformation T which maps alpha to beta, an arbitrary element of alpha, an arbitrary element of V from V to an arbitrary element of W, say alpha and beta. So this T alpha is equal to beta is the map T here. So corresponding to this T, we define a map from this W star to V star. Okay, so we consider a map from W star to V star. So how to define that? Corresponding to each G belongs to this map is denoted by T transpose. T transpose sends G to that uh, F. Okay, so we need to define T transpose as a map from W star to that V star defined by T star. T transpose of G is defined as G composition T. Okay, clearly this is an element of V star. Why it is an element of V star? Because this G composition T is a linear transformation. G is a linear transformation, T is a linear transformation. So composition also a linear transformation. That's from the domain of domain of T to the codomain of G. The codomain of G is F, because this G is a linear functional on this W star. So G is a functional from W to F. If we define this to vector spaces over a common field F. Okay, so clearly this G composition T belongs to V star. Okay, so how will you define this function? G composition T of alpha is equal to T transpose G of alpha. This T transpose G is a linear functional defined by G composition T. So this is the definition of T transpose. Clearly, you can prove that this T transpose is a linear transformation, because T transpose in fact, this T transpose of G is this function, and G composition T is also a linear functional. But we will prove that T transpose itself, so that is a function from W star to V star, is a linear functional. How will you prove that T transpose of C1 times or C times G1 plus G2? We choose two arbitrary elements from W star. This is G1 and G2, and we consider T transpose of this. We will prove that this is same as C T transpose of G1 plus T transpose of G2. So one thing we should remember is these are all functions, or anyway, these are all elements of this T transpose of any linear functional in W star. That is a linear functional V star. So anyway, this is the elements of V star anyway. Okay, T transpose of something is an element of V star, and this is also an element of V star. This is also an element of V star. So how will you prove the equality? In order to prove this equality, equality of elements of V star, we need to prove that this function coincided with this function at every point of V. Okay, so because the domain of this function is these functions are V and codomain is F. So we need to prove that T transpose of CG1 plus G2 of alpha. We need to evaluate this function left side, and LHS and RHS on every element alpha belongs to V. So this is alpha, and it is denoted as it can be written as by definition this is G composition T of alpha. That means this composition C G1 plus G2 composition T of alpha. So that is C G1 plus G2 of T of alpha. So that can be written as C1 G1 of T alpha plus G2 of T alpha. So from this you can write that is this is not C1 this C this can be written as T transpose of G1 of alpha. Okay, so this is of alpha plus and this G2 T alpha is same as G2 composition T alpha. In fact, that is T transpose G2 of alpha. From these two terms, you can say that this is equal to C times T transpose G1 plus T transpose G2 of alpha. So we have this equality LHS and RHS. So anyway, once you define this T transpose is unique up to this T. Whenever T is defined, then T transpose is defined. Okay. So the T transpose of G varies anyway. T transpose of G will give different linear functions. Anyway, T transpose the map the rule is fixed if T is fixed. That means this T transpose depends only on this T. Okay, when T varies, then T transpose varies. So this proves theorem 21. Any This is theorem 21. It states that let V and W be two vector spaces over the field F for each linear functional linear transformation T from V into W. There is a unique linear transformation T transpose from W star into V star such that this holds. Okay, that's what we have proved here.